Happy Hot Monday. Here's some things I could find that would be helpful for people chasing down electrical issues. Even when you're reading proper battery voltage, it doesn't mean that your wire carrying the voltage is good, or it doesn't even mean that your module that you're trying to read from, it's got 12 volts, is good. The thing about electricity is you've got voltage and you have amperage. You can have a wire that can test well for 12 volts, but it does not carry the required amperage to enable whatever you're trying to enable at the end of that circuit. Mower here had a no start, so I started just off of the solenoid wire here. The first thing I noticed is I had no voltage to this. The factory connector broke when I pulled on it, so I replaced it. This crimper right here is the best for this style or any sort of weather pack connector. These are the crimpers you want to have. These are going to roll into a barrel type crimp. A little belly here with a ridge. I'll show you what that looks like when it crimps. So this is what actually is the solenoid trigger wire. I put a new end on here. I was not reading voltage before, and now I am. I'm matching battery voltage, but it does not start or even enable this, right? So anybody else would test that out and say, okay, well, I've got 12 volts going to it at start. Well, something's wrong with the starter. Well, I know the starter's fine because I tested it manually. The problem is that wire has the ability to carry voltage at a very low load, which tells me something up the circuit stemming from original battery source, key switch, something has restricted the flow of electricity, or what we call an electrical restriction is resistance, is ohms. So it's going to have a high ohm rating. Now I could do an ohms test, but this is just cut dry, stick it, make it work. It doesn't show the wire going to the starter, but it comes from here. You see this green and white wire? This changes to the light yellow little lead that goes directly to the starter. Now this is your engine harness. We're going to zoom out here and I'm going to talk you through this. So let's go backwards. From green, white. Goes up to the engine harness adapter, which just sticks in right here. So this connects where this connects. Alright, so we run the green out. Okay. This does go to a diode and goes to ground. But for the moment, I'm going to chase this upstream. So we go up. It goes, still identifying what it is. White with green tracer, or green with a white tracer rather. It goes up to the relay. You're thinking, oh.
Well, of course it's the relay. Why didn't you check there first, Ty? You stupid?
No, I did check the relay. Guess what? The relay clicks, it ticks, and when you test it, it has 12 volts. Now you see the way these relays are, right? It's just your generic 5-pin relay, okay? The way these work, this is your wire that essentially goes to your starting solenoid. It's a carry through power from this yellow traced red wire here. Okay, so what happens, the way the relays work, it's just a electrically powered switch is all relay is. Okay, so the idea, the goal of this relay to function is to carry this voltage, which is 12 volts, Didn't know about the amperage yet. Okay, we don't know what the draw, what the ability to carry current, but I'm just specifying how this relay works. So this power sits here at this pin, and the relay's goal is to get the power to go to this wire. The negative for the ground is supplied by the safety interlock module, and the hot here is supplied all the way back from key switch, I believe. Yep, it runs from the key switch. So the key switch is your hot, and your ground is supplied by the interlock safety module. And so what happens is when the hot and negative are controlled by the safety module, it allows the contactors to pull in inside this relay, and it's going to allow this circuit and this circuit to become connected or closed. The circuit will close, allowing the power to pass through. So what's happened is I've tested the voltage coming through, voltage, and it reads fine. Everything tests out the way it would if you were just testing for voltage. But here's where I starting over again, directly from the power going to the relay. Now this gets its power from the amp meter, and the amp meter, follow this down. See, I got this right here. They've got a connection that comes together on the positive side of the amp meter, and it's spliced together. So this basically it runs its power. It's not coming from the amp meter, it's spliced power right here. So we go back from this red all the way to this 20 amp fuse. Okay, and then we go back from the 20 amp fuse all the way down, all the way around to the engine adapter, and essentially it brings us to the positive connection all the way on the starter. Okay, so what I've done is I checked the fuse is fine. So I took a jumper lead and went from different sections in the wiring to the starting solenoid. So I took gator clip, got these two gator clips connected with a switch, so I could complete the circuit. I started at the basic. Okay, I had my jumper lead all the way off screen here onto that little bitty tab on the starting solenoid. I ran the other jumper to the battery, and the engine cranked full power. So I said, okay, that's the hot lead coming from the starter. So I found up where this circuit went and just chased it back up to this fuse block. I'm like, well, we'll skip a couple connectors and just go to here. So I tried to start it off of one side of this fuse here, which would actually be this side here. I took the fuse out and stuck a pin down in here, and from this the engine would crank. Okay, and with the key on it would actually start, but it would crank. So I know that this wire going all the way from here to its power point on the starter is good. Okay, it has enough ability to hold enough amperage to enact the solenoid. So I went to, where is this going now? All right, put the fuse in. This is where it ties into the amp meter here. So I stuck my gator clip now on this connection and to the solenoid on the starter, and it started. Okay, it cranked, it worked fine. So I know that we're good from this power supply link into here. I'm like, okay, well, let's keep tracking power. Go to where it ties in over here at the relay. Stuck the gator clip on this lead and from the starter, and it starts. Well, the problem is I put the relay back in. I stuck my lead on this pin right here, and you know what happened? Nothing. The relay clicked, the relay tested, it was reading 12 volts. It was reading 12 volts from here, but it was not pulling the amperage required to pull the starter. Because once I supplied 12 volts to this wire separately, disconnected from the relay, it works. So what's that tell you? Yeah, Tyler, the relay is bad. But if you test it through traditional methods of just voltage testing, it's going to look like it's fine and it works. And if you got good ears, you can hear it click. The contactors are pulling in there and it's reading like it is transferring the voltage from the supply to where it needs to go. But the relay is failed internally in its ability to carry a current required to enact the solenoid. I know that's going to fix it because I've got a good ground supplied by the interlock module. All the safeties work. I've got good power coming from this key switch. The key switch is fine. Everything's been tested. It works there. So I know this relay, although it tests well when you're voltage testing, it does not hold the current to actually enact the starter. Long-winded to say, just because it tests 12 volts doesn't mean it's going to pull the current required in that circuit. So you can do load testing, or you can just run around and do a couple like I did. You could load test and actually get voltage numbers, or you could just do different sections in that circuit and see at which point did you go too far to where it's not going to start. Once I passed that step in the mapping, it failed to enact the circuit. So I know that relay fails to carry the current required. So for the sake of testing pins, I've actually taken these spade connectors, females here, out of the plug for the relay. These are a nice tool to have for disassembling electrical connectors, and it's actually part of a kit you can order on Amazon or wherever. So terminal release tools. This will get you into most of your weather pack connectors. And they're actually, for what they are, they're pretty sturdy. They are invaluable. Even if these things cost $100 for these 3 out of bottom, I think these were pretty cheap. But you use this to release these little tabs inside of the keepers here. So when it's up in here, you'll see, just shove them in to release, and you pull them out the back. So it just releases this little tab. That's it. Show you how I got there. So what I've done, for the sake of all fun and purposes, yes, that's a Ford relay. That's what was in here. Don't ask questions. I don't know. So this relay, you can feel it. All right. Clicks. You can even hear it. That's not the key switch you're hearing. You're actually hearing that tick. Let me show you. I've got my ground connected to the battery terminal. So let me show you. I'm going to have hot voltage on this red back here. Okay, so I've got battery voltage, and I'm back here on this red and yellow wire, which according to the diagram on this relay, that is terminal 30. So the objective of the relay is to get the power from pin 30 to pin 87 whenever a hot and a negative are applied to these two terminals. The safety provides the ground through the interlock module, which is that box down there, and all it does is make sure all your brake switches, neutral switches, everything else are in place before it allows you to start the machine. So once that has a ground, it's good to go. This gets it hot from the key switch, and you'll see, I'm going to hold it right here. See, when I'm in the start position, we have 12 volts. So, and I could check, I know this ground is good, I know this ground works because the relay is working. Now, since my goal is to get the voltage from pin 30 to 87, I'm going to check voltage at 87 when I'm in the start position. So I'm going to be right here. There's pin 87. Alright. Well, now it's just being funny. Earlier it was actually showing 12 volts. Anyway, what happens is you try to start it, starts, because this is not carrying the current through to this lead going to the starter. So watch this. New relay, same designation, how it works, but this time does something a little different. It starts. That's it. Have a great day. It's hot.